In this set of video notes, we're going to do part 2 of 5.3. First thing we're going to look at is projectiles. So that is an object that is thrown or launched into the air, such as a baseball, basketball, or soccer ball. That's known as a projectile, so whatever you're throwing. The general function that approximates the height, h, in feet of a projectile on Earth after t seconds is given by, and you might have seen this in physics, -16 is feet per second squared for gravity. We have t squared as our time, plus v naught, which is our initial velocity. So when it leaves whatever it is from your hand, from your foot, from the golf club, that's your initial velocity. T again is time, plus h naught. H naught is the initial height. It's in feet because -16 is feet per second squared. So make sure you're using the right equation for the right thing. So if we have meters, that's a whole different setup with, it's not -16 because that's in feet. So let's take a look if we have a problem like example 3. So it has a note. This model has limitations because it does not account for air resistance. So it doesn't account for air resistance, doesn't account for wind or any other real-world factors. It just assumes that nothing is acting upon it. So if we have a golf ball hit from ground level, so that is our initial height of 0, so it starts off at the ground, and an initial velocity, which we know is v naught, and it is 80. After how many seconds will the ball hit the ground? So we have h, the height of t, or the height with respect to t is -16 t squared, because it's in feet, plus v naught, which is 80, times t, plus h naught, which was 0, because we're hitting it from the ground. And the question says, when will the ball hit the ground? So h of t is the height at t seconds. So what is the height? Well, the height is 0. So our ending height is 0 equals -16 t squared plus 80t plus our initial height is 0. So now if we look at it, we can solve. So we have 0 equals -16 t squared plus 80t, and we don't need, oops, there's a plus 0 in there. We don't need plus 0. So now we can actually factor. So if I look at t squared and t, the two terms, I can factor out, they both have -16 as a factor in common and a t. So if I divide out -16t from -16t squared, I'm left with t. And if I divide out -16t from 80t, I'm left with -5, because -5 times -16 is +80, and then I have my t. So that all equals 0. Now, going back to when we used to solve polynomials with factors, we take -16t, set it equal to 0, divide by -16, and time is 0 when the height is 0, which that makes sense because we hit it off the ground. That's not really what we're looking at. We want to see how many seconds till it hit the ground again. So t minus 5 equals 0, add 5, t equals 5. So this is the one we want. That is after it went up in the air, it came down at 5 seconds, it hit the ground. So 5 seconds is when it hit the ground. So that's the one we want. Quadratic expressions can have 1, which would be like this. That's just one term. That's a monomial. It can have 2 terms, which is a binomial. Or it can have, whoops, this one actually goes to the next line, plus 2. That is a trinomial because there are 3 terms. Some quadratic expressions have perfect squares, and we can have special factoring rules for those. So if we find out that our expression looks like this, where we have something squared minus something else squared, we can factor it into a plus b, a minus b. If we have a squared and b squared, and then we know that a times b in the middle that's doubled, then we know it's a minus b quantity squared. If we have the same thing with plus 2ab in the middle, then we know it's a plus b squared. So let's take a look at our examples. The first one, we're going to move everything to the left-hand side, so minus 25 minus 25. Then we get 4x squared minus 25 equals 0. And we can look at 4x squared is really 2x squared, because 2 squared is 4, and x squared. And then minus, what is 25 squared? Well, we have 5 squared makes 25. So that follows along with our a squared minus b squared. So our a is 2x and our b is 5. So we end up with 2x plus 5, 2x minus 5, and that equals 0. And then going by our rules before, we take 2x plus 5 equals 0, solve, minus 5, 2x equals negative 5, divided by 2, and x equals negative 5 halves. And then we go ahead and set the second one, 2x minus 5 equal to 0, add 5, and we have 2x equal 5, divided by 2, so x equals a positive 5 halves. So those are our two answers. In example B, we want to get all of the information on the same side, so we have to move the 48x over and the minus 32. So we get 18x squared. We subtract 48x to move it over with the x squared. We add 32 to move it over with the x squared and the x, and then we end up equal 0. And what we want to do, what can we do to this? Can we divide anything out? Well, we can divide everything by 2. So let's factor out a 2. And then if I divide 18 by 2, I get 9x squared. Minus, if I divide 48 by 2, I get 24x. And if I divide 32 by 2, I get plus 16. And now I can look at, I have 2, but inside I have 9x squared is really 3x squared minus 24x plus 16 is really 4 squared. So now we have 2 times, and 3x is our a, and 4 is our b. So if we take 3x times 4, we get 12, and 12 doubled is 24. So we really have 3x minus 4 quantity squared equals 0. And then I can actually solve it. So if I divide by 2, I get 3x minus 4 squared equals 0 divided by 2 is 0. Square root both sides. So I get 3x minus 4 equals plus minus 0, which is 0. And then I can subtract 4 and divide by 3, and I get x equals 4/3. So let's split this up here. And in the next example, I want everything on the same side, so I need to add 4. So I get x squared minus 4x plus 4, because I added it to the other side, and I get 0. And if I look at, I have x squared minus 4x plus, this is really 2 squared equals 0. So then my a is x and my b is 2. So if I take 2 times x, that's 2x, and I double it, do I get 4x? Yes. So again, it's with the minus. So I have x minus 2 squared equals 0. And then I can go ahead and solve. So square root both sides. And I get x minus 2 equals positive negative 0, which is 0. Add 2, and x equals 2. Now in the case of B and C, I'm only coming out with one solution, but yet I know it's a squared. And the reason that it's one solution is because I have x minus 2 squared. So I have this right here, which I know is a double root, so it's just going to bounce at 2. And I know that this is also a double root, so it's going to only hit once. So you may not see that we have two answers because it only hits the x-axis once. In D, we have let's just split this up, 25x squared, and then I'm going to subtract the 9 to get equal to 0. And I know that that is 5x squared, because 5 times 5 is 25, x times x is x squared, minus 9, which is really 3 squared, equals 0. So in that case, I have something squared minus something else squared. That goes back to my original problem up here. So I end up with a, which is 5x, minus b, which is 3. And then I have 5x plus 4. So let's kind of bring this down here. So we have 5x minus 3, so that's a minus b, and 5x plus 3 equal to 0. And then we go ahead and set 5x minus 3 equals 0, add 3, 5x equals 3, divide by 5. So I have x equals 3/5, and 5x plus 3 equals 0, so I subtract 3, and I get 5x equals negative 3, divide by 5, divide by 5, and I also get a negative 3/5. So we get a positive 3/5 and a negative 3/5 for our answers to letter D. In our last two problems, it looks like what we have done in the past. So this is really zeros, so we really have f of 4 equals 0 and f of negative 7 equals 0. And we know that quadratic, we have x minus 4 is one factor and x plus 7 is another factor. And then they want us to write the function in standard form. So let's x times x, let's FOIL it out, and x times 7 is 7x, and the insides are negative 4x, and the last are negative 28. Combine like terms, so I have x squared plus 7 minus 4 is 3x minus 28, and that is our function. In letter B, we know that f of 5 equals 0 and f of negative 5 equals 0. So then f of x equals x minus 5, and then x plus 5. And if we put that in standard form, we have x times x is x squared, x times 5 is 5x, negative 5 times x is the insides, negative 5 times 5 is negative 25. Combine like terms, so f of x equals x squared, 5 minus 5 is 0, minus 25. And that would be our function in standard form. So in this video we talked about special factors. We have the difference of two squares, and we have perfect square trinomials, and we were trying to factor them. And we also did projectile motion with an initial height and an initial velocity, and then an ending height of 0.